Section 4.7, congruence in overlapping triangles. And the objective is to identify congruent overlapping triangles. That's the first part. That's going to be the easy part. And then to prove two triangles are congruent using other congruent triangles. That's the hard part. Okay, so problem one. The first two problems, you guys are going to go, whew, that's easy. So here we go. Problem one, identifying common parts. What common angle do ACD, triangle ACD, and triangle ECB share? What do you guys think? C. Now, did you guys look at the picture or did you look at the letters? Okay, I looked at the letters because that's what I do. I like the letters better. Just because the picture sometimes gives you kind of a harder thing to look at. But also, if you look at the picture, if you look at the letters there, A, B, C, D, E, C is the only one that's going to be in both of those. One thing that you might want to do is separate those triangles. So I'm going to draw those. No, you can sit in here in one of the back desks. It's fine. What? Mm-hmm. Okay, so ugly triangles there, but I'm going to put the letters in. So then when you look at those angles, the ones at the bottom are the same. Same letter, they overlap in the exact same place. It would be angle C. Here on this one, I wouldn't make you do 3 letters. They're overlapping and normally you do, but they're just looking for the part that's the same in both. The thing that I looked at in this one is when I looked at ACD and ECB, the thing that was the same in both is C. So again, if you wanted to do 3 letters, you could do angle ACD and angle ECB. They are the same. On this one, I'd let you do 1 single letter. Okay, so that's what you do if there's a common angle. What do you do if there is, I think there was one more with a common side. Yeah, it's this one. I just put it on the top there. Yep. Okay, so what about this one? What is the common side in ABD, DCA? Okay, so I'm going to look at only the letters first. ABD, DCA. What are the letters that appear twice? D and A. So notice how I'm underlining those. You're going to say side AD or segment AD or DA. Okay, that way if you look at the letters, if they actually give you them, it kind of gives you the exact same letters. If it's 1, it's probably an angle. If there's 2, it's a side. And it does say what's the common side anyway, so you do have to put a label on that. When you're looking at this one, if you wanted to do highlighters to help too, you could go like this. ABD is this one. Wow, that's thick. Just a second here. And the DCA is this one. And if you look at where they overlap, that would be the part that's the same. And here you're looking for sides. So it's not AB, it's not BD, it has to be AD on the bottom. So you just go through each part and it would be this one right here. That part on the bottom is where they overlap. Okay, so that's one way you can do it. If you have highlighters and you want to highlight on the test or quiz, go for it. So now I'm going to erase those because we have one more. Okay. Common side in ABD. I'm going to make this a little bit smaller this time. ABD and BAC. BA. Okay, so now on this one, AD is not it, AB is the one where they have the two colors, and then BD only has like half C's. It's half colored and half not, so it has to be the entire thing. It's going to be BA. If you only look at the letters, AB matches BA, and the order of the letters doesn't matter. So we'd say side AB on that one. So that's going to be the easy part. Now we get to the proofs, and you might want to write down at least one of these, and then for sure the last one. I think there's 3 that we're going to do. So with the first one, we are not given congruent triangles at the end. So once we actually put that in there, we need a congruent triangle statement above that one. Okay, so that's just a little hint. And then it is 4 steps, so we're going to need to fill in only 1. So I'll give you a minute to write that down, and it's 4 steps. Okay, so in this proof, we're given a couple of angles that are the same, but notice how they overlap each other, and it's kind of hard to figure out which triangle is which. Sometimes on these, you might want to break those triangles apart. So I'm going to draw triangle ZWX on the left. And I'm going to draw the other one on the right. And kind of draw them so they kind of match with what they look like, instead of just doing like some acute triangle or something. This gets a W. And then I'm going to mark them. So ZXW, that's this one, matches YWX, that's this one. The other one, ZWX, is this one, matches that one. So it's kind of a little bit easier to see what you're kind of looking at instead of having them all mushed up together. Now, on this one, I'm going to do the given. So again, just so that we don't have to waste a bunch of time, I'm going to put this in here on the first step, and that's going to be my given. And then my last step is going to be segment ZW congruent to segment YX. We don't know the reason for that yet, but we do know that that's kind of where we are at. Now, when I broke this apart, we know already that this could be corresponding parts of congruent triangles, maybe. But we also know that before that, we probably have like a congruent triangle statement of some sort. So it's probably going to be triangle ZWX congruent to triangle YXW. So how are we going to get those triangles the same? What are you guys thinking if we look at the list of 4 things that we've used so far? Which ones can we cross out? 1 or 1s, I guess. Can we do side, side, side if there's 2 angles there? No. Probably not. So we can at least get rid of that one. Would we probably do side angle side then if there's 2 sides marked? Probably not so much. So we're really down to 2. So if you guys can eliminate a couple of choices, even then if you guessed, you might just get it. So what we're looking at is, when I look at this thing, do you think we can get, let's see, angle, side angle would have to make this one the same as something else. Angle, angle, side would either be angle, angle this side, and we know it's not that because that needs to be the one at the end, or angle, angle that side. So what one do you think it's going to be? Angle, angle, side, or angle, side, angle? Yeah, and how do we know that that side is the same? What's the reason for that? Reflexive. And for that one, you might want to look back at this one because it shares a side with itself. So anything touching that shares a side, or it's overlapping and shares a side, you know that's reflexive. So we're going to go WX congruent to WX. And now we can do corresponding parts of congruent triangles are congruent. So I was thinking that that was probably the reason, but sometimes it's not. Okay, on this one it happened to be that way. Because once the triangles are the same, then everything else about them is the same. So here's our second one. This one is 3 steps. I'll make it a little bit bigger so you guys can copy this one. Okay, so this one starts with a congruent triangle, which is different. Triangle ACD, congruent to triangle BDC. Given. Okay, so let's look at those. ACD and BDC. Okay, and this might be something that you want to try too. If you don't want to redraw them, maybe you want to just highlight the ones that you're looking at without coloring them all in. Now, the thing that's goofy about this one too is that at the end, the things that we want the same are this one. Those little segments that are kind of hanging out in the middle, which kind of look funny. So we haven't done anything like that before either. So since we have congruent triangles, we know that every single part of those is the same. Every single corresponding part is the same. So angle A and B are the same. Angles C and D are the same, and so on. We could do sides as well. What we need to do is we need to be really selective about what we put here on the next spot, and it is going to be corresponding parts of congruent triangles are congruent, but what is it? Okay. Do you remember yesterday when we did those isosceles triangle theorems? Okay, that's kind of what we're going to be thinking about. Okay, so if we have a congruent angle, we could go to the side opposite it, right, to find the two sides that are the same. That's going to be kind of what we do. So in this one, we want to be selective, and I'm going to pick these base angles right here to be the ones that are the same. Because I know that angle C, this little angle C, BCD, goes to side DE, and I know that angle ADC goes to the side CE. And that's kind of what my thinking is. So those are the same. So we're going to go angle, and I want to start with the purple one first. Angle BCD are the one on the left. BCD. No, I need to go the other way. ADC. Congruent to BCD. And then my last step, I know that CE is congruent to DE. When the angles are the same and you're trying to get the sides the same, it's the converse of the isosceles triangle theorem. When it's the sides the same first and you're looking for angles, then it's the regular theorem. So something different. I wanted to show you that just because sometimes they do give you congruent triangles at the beginning. If they do, then you wouldn't have a congruent triangle statement in the middle, and then you wouldn't have to pick from side, 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 angle, side, and those 4, okay, because they would already have it. This is the one that I would like you to write for sure, just because it is 6 steps, kind of long. Also, it has kind of 2 parts to it, which is different. Okay, so I want you to probably copy this whole thing, and I'll give you a second to do that. So this is the last proof, and it is 6 steps, kind of comes in 2 parts. On the quiz tomorrow, I will kind of give you a few hints on this one, where the other ones you'd have to kind of do on your own. With this one, you're going to have a little brace on the side that says large triangle, and you're going to have a little brace on the side that says small, just like we're doing it here. That's why I wanted you to write it down so you'd have something to go by. And we're going to look at that now. So this is the first one that they've actually used 2 different parts of these triangles to find out what we're missing. So I'm going to write the given in there. Segment PS congruent to segment RS, and those are marked, and angle PSQ congruent to RSQ. The last step, triangle QPT congruent to Thank you. I don't know the reason for that yet, so I'm going to leave that one blank. So on this one, the first 3 steps are going to go with a large triangle. The last 3 steps are going to go from the small one that I'm going to draw. Okay, so then you would have to figure out what's my large triangle, what's my small triangle, okay? So on this one, they want QPT, like this one right here, and this one, the same at the end. That's my small triangles, okay? And since it is at the end, that kind of indicates the small one. So I'm going to draw those. And you can either separate them or do side by side. It doesn't really matter. It might help if you just keep them the same. Okay, so that's my small. Now I got to figure out what's my large triangle. And what I'm going to do is I'm going to use the left half and the right half. So you have 2 small triangles kind of intermixed with the big one. I'm going to do the big ones. So I'm going to do these in a different color so you kind of know what part goes with which. So now I'm going to draw these 2. Without that inside stuff. And I've marked those parts that are the same. So for the first part, I'm going to use the purple one. Second part, I'm going to use the pink one. All right. So if we look at it, we have a side congruent to a side and an angle congruent to an angle. Anybody see anything else that's the same for sure? Yep, QS and QS are the same because of what's the reason? Reflexive. Are we getting good at reflexive now? Good. That's, like I said before, that's about the only property that I knew, I felt like, when I was sitting where you are. So QS congruent to QS. So I'm going to mark that one. Are these triangles congruent now? Okay, so by how? What's the property that we, or what's the theorem that we would use? Yep. And what you would do then is, okay, do I have side, 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 side angle, side? Which ones can I eliminate? Which ones can I use? On this one, it is not side, side, side because they give us an angle and they need us to use it. So this one we can only really narrow it down to 3. And when you look at just one half of the triangle, there's a side here, an angle here, and then that side is the same. So it is side, angle, side. Triangle. And a little tip too, some people are like, oh, I'd never know how to name these things, to know how they're named. If you're given a 3-letter angle name up there and it matches the letters of the triangle that you're doing, just use them in that order. So when I'm looking at PSQ, does that work? It does. So you can use those so you don't have to like recreate anything that you don't have. But if it doesn't match the triangle that you have, then you can't do that. So I'm going to go triangle PSQ. Congruent to triangle RSQ. Okay, so the large triangles now are done. I want to go to the small ones. How do you know what to mark when there's nothing marked in there? Okay, here's where the tricky part comes in. If the triangles are congruent, aren't all other parts the same in the left ones now? So here's what I'm thinking. For instance, this angle now matches that one, and this side matches that one, and so on. We could go on and do the rest of it if we wanted. Now, when I redraw the picture, aren't PQ and PQR in my other picture? Now, I can mark this one the same because they're congruent, and that's going to be one of my steps. And isn't angle PQS the same as PQT, like right there? And RQS is the same as this one. So you really do have stuff, but you have to transfer it from here to here, you know, and make them kind of work together. So that's going to be my first step in the small triangle part. And now it's going to be tough because we won't be able to see it, but I'm going to go with PQ. These are the sides that match. Congruent to RQ. And PQT. Congruent to RQT. And the reason that they're the same is because we use corresponding parts of congruent triangles are congruent. When we look back up at this picture, we need another part. Will it be another side or another angle? What do you think in the small pink ones? And it'll be QT is right. So we use reflexive again. So QT, congruent to itself. Reflexive. Make sure you put property of congruence on there. And let's look and see what we have marked up here again. So now if we look at the pink one and the triangle, that what we have marked side, angle, side. So we're using side, angle, side again. It's just a different set of triangles. So nothing says that we can't do side, angle, side twice. Would it have to be the same on that one? No. It could have been side, side, side on that one, depending on what it looked like. But most of the time it matches, but maybe not always with the two sets of triangles. So kind of tough, but what you guys then will have marked is large triangle will be marked, small triangle will be marked, and you will have where the corresponding part things are. Okay, so I will put CPCTC in there so you know exactly where they are. Just keep in mind that when you see that, the line above it should be a congruent triangle statement, right? So you would have to find what are my triangles that are congruent and how do I know that? And I think that will kind of guide you through the rest. Definitely look for reflexive things. Because that always helps. And even if you leave a couple blank, do as many blanks as you possibly can to get the most points that you possibly can. And this is probably the toughest one that you guys will have this year. I kind of feel like this is the hardest one. So there'll be one like that on the quiz tomorrow. Do you? Mm-hmm. Good. And it might be just be because you're getting better at them because you've seen them enough. Yeah, I always thought when I've taught this multiple times that the side, angle, side, these, because there's a specific strategy that you're looking at and you can cancel some of your choices, whereas the ones that have a bunch of blanks in them, you don't really know what you're missing, do you? It's like there's so many missing blanks that you don't really even know where to start. Here you can go, okay, if I need to get side, that means I need these sides the same. And then you can say, are they or not? You know, so it does make it a little bit easier that way. So your assignments on the board, the 15, 16, 17, 21 on the side, those are proofs. It does tell you the number of steps. I would focus more on this one first for the quiz tomorrow. I'm assuming that that's the large triangle, small triangle thing. The others are not going to be on there because there's one proof on there. The rest are going to be problems from the last couple of sections. Did I talk about it yet, the quiz? Okay, so I'm going to do that now too, just so I don't forget.